So welcome back. We're going to continue building some stuff on complex fractions. We want to kind of revisit the distributive property a little bit. And again, don't forget the distributive property can also be associated with the rectangular model. So the distributive property, we can use the rectangular model as our organizer. So let's look at this example, 41 times 99. You know, we showed you all kinds of ways to multiply 41 times 99. What I want to look at, though, is using the rectangular model to do this. So if I think of 41, I can think of 41 as a 40 and a 1. Now, 99 is actually really close to a special number for us, which is 100. But how do you make 100 turn into a 99? Well, if I write 100 here, I would have to subtract 1 to make that represent 99. So 41 could look like this. 99 could look like this. So again, I can use my rectangular model as a way to organize this math. So 41 is like 40 and a 1. 99 is the same thing as like 100 and a negative 1. So I can partition this off into 4 smaller rectangles. And I can just multiply these numbers together and create the total. So 40 times 100 would be 4,000. 40 times negative 1 is a negative 40. 1 times 100 would be 100. And 1 times negative 1 would be negative 1. So if I play this math out, I would have 4,000 take away 100, or 4,000 plus 100 would be 4,100. 4,100 subtract 6, I'm sorry, 4,100, and I would lose 40. That's going to take me down to 4,060. And then if I lose 1 more, that's going to get me down to 4,059. So notice that this math could be done using a rectangular model, or I can just punch it into a calculator. Now, unfortunately, this cannot really be inputted into a calculator, but what it can be done, though, is I can use this rectangular model to organize this math. So notice how I have these two things multiplied together. So those are going to represent my edges of my rectangle. So x plus 3 is going to go along one edge. So there's my x and my 3. X minus 4 is going to be my other edge. So an x and a negative 4 goes along that edge. So we multiply x times x, we get x squared. X times negative 4 would just be negative 4 times x, or negative 4x. 3 times x is 3x. And 3 times negative 4 is a negative 12. And again, we just add all of our numbers together. But the only thing that really is alike here are these two terms. Those are the only things that we actually combine together. So what you have then is the x squared comes out as a term. Negative 4x and 3x, focusing on the coefficients, a negative 4 and a 3 would give me a negative 1, or just a negative x. And then we'd have that negative 12 as my last term. So this, again, we would almost call like a binomial, 2 terms by 2 terms. So when you multiply a binomial times a binomial, you will get what we call a trinomial, a 3-term expression. So those are some other vocabulary words we'll keep adding into. So if I multiply 5x minus 4 times x minus 6, this math can actually be multiplied by using the rectangular model. So I have 5x and a negative 4, and I have an x and a negative 6. So when I'm doing a multiplication, I have 5x times x. Well, that's just going to be 5, and x times x is x squared. Remember, repeated multiplication, you use exponents. 5x times negative 6 is going to just give me a negative 30x. Negative 4 times x is negative 4x. And negative 4 times a negative 6 is actually a positive 24. And like many of these, you'll see that this little diagonal a lot of times will be your like terms. So your final answer then becomes that 5x squared comes into the problem. This becomes your next term. That's going to be a negative 34x, or minus 34x. And then we have a 24, so and a 24 would go there on the end. So we have a 5x squared